Hello everyone, welcome to the world of data structures. Our today's topic is examples of insertion and deletion in binary search tree and examples of threaded binary tree. Hi, this is your instructor Janice Shah. So let's begin with the outlines. Students, outlines are examples of binary search tree insertion and deletion and then threaded binary tree. Okay, so let's start with the examples of tree insertion and deletion. Students, here this is a binary search tree given to you. Okay, 79, 32, 10, 50 and 46. Then we have 90, 85 and 95 with us. Okay, so in exam you may ask to write or draw tree after each and every insertion and deletion operation. So at that time you do not need to start from the very first figure of your example. You always need to draw or always need to do insert or delete operation from your previous answer. Okay, let me show you how. If this is a given tree, then the first question is insert 48. First is insert 48. So first you will just need to draw this figure, then write insert 48 and then show the answer the after inserted 48. Okay. So students, to insert 48, first I need to compare 48 with 79. Now 48 less than 79, so it must go on the left side of the 79. On the left side of the 79, students, we found 32. Now compare 32 with 48. So 48 is greater than 32. So it must be on the right side of the 32. So there is a node 50. Now 48 is less than 50. So it must goes on the left side of the 50 where I have 46. So 48 must be inserted on the right side of the 46. So here it is. 48 is inserted successfully. Fine. Now the next value is insert 98. Insert 98. Students, if you can see, right now I am just inserting 98 in my previous answer where I have already inserted 48. So again, start comparison from the 79. 98 is greater than 79, so just go move towards the right side. Now 90 is greater than 90, so again move towards the right side. 90 is greater than 95. So students, 98 is greater than 95, so I need to insert 98 on the right side of the 95. Okay, so it is inserted like this. Fine, so this is my answer. Okay, now the next operation that I want to perform, that is insert 83. Fine, so students, to insert 83, again I need to start comparison from the root node, that is 79. Okay, if you can see, my 98 and 48 are already there in the figure. Okay, what I mean to say is you just need to perform your operations in a sequence. First is inserted 48, then insert 98 and then 83. So before inserting 83, your figure must contain value 48 and 98 in your answer. Okay, when I want to insert for 83, first I need to compare with the 79. 83 is greater than 79, so it must be on the right side. Now 83 is less than 90, so must be on the left side. 83 is less than 85. So students, 83 must be inserted on the left side of the 85. That is 83 on the left side of 85. Okay, so now next we have, that is delete 10. Okay, so this is a deletion operation, students. If you remember, every deletion operation we have three cases. Case number 1, where we want to delete a leaf node. Case number 2, where we want to delete a node which contains one child. And case number 3, where we want to delete a node which contains two child. Okay, so what you need to do is, if you want to delete a leaf node, then it is directly deleted from the tree. If we want to delete a node which contains one child, then the child node is replacing the parent node. Okay. And the third case number 3 is, if we want to delete a node which contains two child, then we need to replace a parent node by the smallest value from the right subtree or greatest value from the left subtree. Fine. So to delete a 10 node, we can easily say that 10 is the leaf node. So we can directly delete this 10 node. Okay. So I'm just removing this 10 node from my figure. That's it. This is my answer. Delete 10 node. Next students, I need to delete 95. If I want to delete 95, now tell me, 95 contains any child node? Yes, it is. Which is there? That is 98. So here in such cases, the child node is replacing the parent node. So 95, that node which I want to delete. So 98 it just take place of 95. 95 is deleted, and here it is 98. So after deleting 95, this is my new figure, a new answer. Okay. So if you can see, I'm just performing my operations consequently. Okay, in a sequence of operations like insert, then delete, delete. Now, is there any operation left? Yes. This is, they want that I need to delete 79. Okay. Students, I need to delete root node, or we can say delete 79. Now tell me, this is case number 3. This is case number 3 where I need to select a greatest value from the left subtree of 79 or the smallest value from the right subtree of the 79. So today I am going to show you two different answers of this operation. So first, if I want to delete 79, then first I am just taking the greatest value from the left subtree. So the highlighted green nodes are the left subtree. Now tell me, which is the greatest value? The greatest value is 50. Greatest value is 50. So 50 takes the place of 79. Okay, so just goes like this. This is my left subtree. Okay, I need to select the greatest value, that is 50, and then 50 will take the place of 79. So 50 will be removed from here and it takes the place of 79. Now, what about the remaining nodes? It just contains the space of 50. So 46 becomes here. So this is my answer after deleting 79 and taking the node from the left subtree. Okay, this is answer number 1. Okay, so now the next we have, suppose if I want to take the value from the right subtree, then what happens? See, there is 79 situation. Okay, now if I want to take the value from the right subtree, this is my right subtree, where I need to select the smallest value. So the smallest value is 83. So I'm just highlighting the 83 from here, and then 83 is highlighted. So 83 is the node which need to take the place of 79. So 83 gone and the 79, such like this. So this is a figure after deleting 79 and taking the value 83, that is from the right, that is smallest value from the right subtree. Fine. So this is answer number 2. So here you have two different answers, answer 1 and answer 2. Both are correct. Both are correct. Fine. Now, next we have example of threaded binary tree. Suppose in exam you may ask to write left threaded, right threaded and full threaded binary tree. Then first you need to find out the in order for this tree. So students, for threaded binary tree you just need to find out the first in order sequence. Here our in order sequence starts from 32. Okay, so it is 32, 39, 46, 32, 39, 46, then 48, 50, 83, 85, 90 and 98. Okay, so from here we are just checking our predecessor and successor nodes. Okay, so next is the left threaded binary tree. So how to make a left threaded binary tree? Tree is here, my header node is also there. So first we just need to take the predecessor of 32. 32's predecessor is no one. So its left pointer is modified to point header node. Next we have 39. 39 is pointing to 32. Okay. Next we have 48. So students, 48's left pointer is modified to point 46. Next, is there any left pointer? 85. 85's left pointer is modified to point 83 and 98. 98 pointer modified to point 90. So this is your left threaded binary tree. You just need to, after writing the in order sequence, you just need to draw this tree. That's it. Okay. Next, the right threaded. Okay, the first is 50 to 83, then 39 to 46, then I just forgot to write like 48 to 50, okay, then 85 to 90, and then 98 to hidden node, because 98 does not contain any successor nodes. So this is your full example of full threaded. So this is our left threaded and this is your right threaded. Both combines together, it becomes full threaded binary tree. So such like this you can write in your paper or in your exam. You can make left threaded, full threaded and right threaded binary tree. Okay, so that's it for today's lecture. Thank you so much, students.